Hi guys, my name is Milton-Barker. I'm the founder of Tech Bubble Technologies and also an Intel software innovator. I work a lot on artificial intelligence and the Internet of Things, and that is what my main role in the Intel software innovator program is. At the moment, my main focus is around natural linguistics and computer vision and how the two can integrate with the Internet of Things to create intelligent automated environments. So my talk is focused around real-world examples that I currently develop more than a technical breakdown of developing the technologies, but I'll explain the various technologies that I use through the development of these projects, and I've also made the source codes available in our GitHub, including full walkthroughs to help you get started in machine learning and the IoT. So here's a bit of background info on how I became involved in artificial intelligence and the Internet of Things. I began developing around 14 years ago. My main involvement in development for a number of years was websites, Facebook applications and games, and business administration systems. I began to work on a platform that would allow me to run my business by automating as much of it as possible, which has evolved over the years to what is now known as the Tech Bubble Technologies ecosystem, powered by Arc, which is the latest version of the Tech Bubble GUI, and Tia and Toa, my online AI assistants. In 2013, I came across a markup language known as Artificial Intelligence Markup Language, or AML, which is an XML-compliant markup language developed for natural language understanding. At that point, artificial intelligence was beginning to push its way through to the general public, but not many people knew about AI or chatbots. I began developing Toa, the Tech Bubble online assistant. Toa was originally designed to assist me with running my business, to assist my customers to run theirs, and to provide help for people using the websites I built. Toa at that point was an online system and included speech recognition and synthesis through the browser, and the natural language processing was powered by Taml, which was my own implementation of AML. I was also working on a number of projects through OIS Core, the Online Intelligence System Core, that included C++ NLP agents and a medical neural network built in Java. In 2014, I received an Intel Galileo from Microsoft for a project idea I submitted to the Microsoft Developer Program for IoT, and not long after that, I began to work on creating projects that allow Toa to communicate with IoT devices. I had noticed a massive disconnect between the general public and technology, especially regarding artificial intelligence, so I began writing a weekly article named Tech Bubble in the local newspaper and publishing articles on Tech Bubble info and social media. I was also running a number of technology-focused pages on Google+, including my own, Tech Bubble and OIS Core. I was writing and sharing a lot about artificial intelligence, and over the next couple of years, the pages generated nearly 1 million views between them. Many years later, Toa and TAS, which is the current version of the project idea I submitted to Microsoft, are still one of my main focuses. I've developed a number of systems that include Toa and Tia, who is powered by my own NLU, such as the AI e-commerce store. A project we recently debuted at Collision Conference in New Orleans and recently demonstrated at Web Summit in Lisbon. The TAS project has received a massive amount of support from Intel over the last year, who provided me some amazing hardware and software to enhance the project, and also provided me some really amazing opportunities, such as presenting the project at the official Intel booth at CodeMotion in Amsterdam earlier in the year. So that was a quick run through of how I got into AI and IoT, and a brief intro to some of the main projects I am working on. So let's get on with the talk.
AI is a fundamental risk to the existence of human civilization.
So as you saw in the video, there are many use cases of artificial intelligence and many real-world examples of AI and machine learning helping to better the world around us. My talk today is about how artificial intelligence and machine learning can be used in the Internet of Things. I will briefly touch upon the use of machine learning in the cloud, and we'll also talk about machine learning on device and the edge as opposed to the cloud. I will use the TOA and task projects as examples and show you some demonstration videos of the projects to give you some real-world examples of how AI can work seamlessly with the IoT. So, machine learning in the cloud. Although AML played a large role in the development of TOA in the early days, and it more or less did what I needed it to do, I began to realize that it was not really scalable. The training process was very long-winded, as I had to provide every possible way that a person could say something so that the intents would match. Plus, it was becoming a kind of outdated technology. I had created my own version of AML that I named TAML, which made it more suited to my needs, but scalability and response times were still a concern I had for the future. Through my research for AI articles, I began to take an interest in machine learning. Although I had a good understanding of AI from what I had learned through writing the articles and my experience in working on the medical neural network, I still had not totally grasped machine learning. Machine learning in the cloud was becoming quite popular, with a number of services becoming available such as Microsoft Cognitive Services, API.ai, now known as Dialogflow, IBM Watson, and many others. This seemed like a good place for me to break the ice, so I began to look into the various cloud services available so that I could rebuild TOA using machine learning and work out how these types of platforms function. In addition, I had also been taking various MOOCs in computer science, IoT and machine learning, such as Stanford Machine Learning on Coursera, and more recently the Deep Learning specialization. After testing systems made with Microsoft Lewis, IBM Watson, WIT AI, etc., I decided that API.ai was more suited to my needs. So I replicated the TAML version of TOA using machine learning through their platform. I have many use cases for TOA, but as this is an IoT conference, I will show you how I use TOA to communicate with IoT devices I have built. The following video is a video that I have used in a couple of previous talks. So if anyone has already seen this, I apologize in advance, but it does provide a good example of how machine learning in the cloud can be used in connection with the IoT. This video shows the previous version of the TechBubble GUI and how I could monitor and control IoT devices with the use of natural linguistics in the cloud. Okay, so as many of you probably know, towards the end of last year, Mark Zuckerberg released a demo video of his artificially intelligent smart home that he'd been building. What some of you might not know is that last year I was also developing an artificially intelligent smart home. I developed the majority of it from the bottom up. I developed the communication platform, which is the TechBubble IoT Jump-Way, which allows the devices to communicate with each other autonomously. It allows the AI to communicate with the devices, and it allows the applications to communicate with the devices and the AI. I also developed the devices for the demo myself, the very basic prototypes at the moment. On the top left we've got a temperature and humidity sensor. On the bottom right we've got the entry sensor for doors or windows. We also have the Raspberry Pi artificially intelligent video camera, which can see through a connected webcam and identify people that it's being trained on. And then from my other demo videos, the IoT connected light, which can be controlled via the IoT. So what I'm going to do quickly is give you a quick demonstration of the application and me interacting with the artificially intelligent agent to control and monitor my smart home. Can you tell me if I left the small light on in the office, please?
The small light in the office is on and has been since 9:32 today.
Can you turn the small light off in the office, please?
The small light in the office has been switched off.
Okay, thank you.
A-OK.
What is the temperature in the office?
The latest reading from your TTM device in the office is 38.00 degrees at 9:37 today.
Did I leave the front door open in the office?
The front door in the office is closed and has been since 8:17 today.
Is the front door in the office open?
The front door in the office is open and has been since 9:37 today.
Okay, thank you.
No problem. TOA voice recognition system is now deactivated.
Okay, so just a few quick examples of some of the new features. The voice recognition in the web browser still isn't spot on yet. We're actually working on our own ASR at the moment, but at the moment we're using the WebKit speech recognition API. So there's going to be more demos, more devices and things to come, so that's part of my artificially intelligent smart home.
So in that video, I was able to demonstrate a number of examples of using machine learning in the cloud with the IoT. In the example, the speech synthesis and recognition, the parts that allow TOA to speak and hear, are cloud-based. The natural language processing is done through the cloud, and the intent and entity classification determines how TOA should communicate with the tech bubble IoT Jumpway, my IoT platform as a service that uses MQTT, allowing TOA to monitor and control the IoT devices. In some cases, using cloud services for machine learning is just not feasible. One such case is using machine learning for computer vision in a real-time environment. Which leads me to the second project I will talk about, TAS, the project that originally got me into the Internet of Things. There have been many versions of TAS over the years. 3 of these versions have been made available through the TechBubble Technologies GitHub with tutorials on how to connect them up. Each version has different features and each uses different technologies. One thing that has stayed constant with the various versions is that they have all done the processing of the video locally, whether on board or via a local server. There are a number of reasons for this. The main reason being that to process one or more video streams 24 hours a day, 7 days a week, would run up a rather large bill. Plus you have latency issues and response times to take into consideration. Another reason is privacy. One of the things I pride myself in is taking as many precautions as possible to uphold people's privacy and security in any of my projects. If you use cloud-based machine learning for computer vision, then the frames have to be sent to the cloud. This means that whatever service you are using has access to a very personal area of your life. This is something that I've worked to avoid. Incidentally, this issue is equally true for NLP, which is why I began to develop Bubble NLU, which is our own NLU engine. I will take you through the several versions of TAS and explain how I handled the video processing locally. The first solution was to use OpenCV and HAR cascades with an Eigenfaces model. Users could upload their training data through the TechBubble GUI, which was then sent to the device via MQTT for training on the device itself. This solution was good as a proof of concept, but identification was not totally accurate and processing time was quite slow. This solution has now been opened up as an example for the IoT Jumpway developer program and is available on the TechBubble Technologies GitHub in the IoT Jumpway Raspberry Pi repo. The second solution was developed whilst at the IoT Solutions World Congress Hackathon in Barcelona and won our team the Intel Experts Award for building a deep learning neural network on the Intel Joule. This solution included OpenCV to detect faces and Caffe to identify them. Although we managed to build the neural network on the Joule, we were unfortunately unable to complete the full functionality of the automated smart home, but had a great time working on the project and were honoured to win the Intel Experts Award. Our use case for this project was automated healthcare rather than security. The idea was that users could train their device to recognise dependent family members and communicate with a smart home to change the surroundings around the dependent family member's needs. The third solution was to use OpenCV to detect faces and pass them through a custom-trained Inception v3 model using TensorFlow. I created the ability to carry out transfer learning directly on the device, which was a Raspberry Pi 3. Users could upload their training data via the TechBubble GUI, which was sent to the device via MQTT for training. This solution was a massive improvement, and accuracy for detecting known people was almost 100%. Unfortunately, I identified an issue which I now know to be a common issue at the moment, the open-set recognition issue. The open-set recognition issue is where the network will identify anyone that was unknown to the network as one of the known people. For the fourth solution, I used a system that I developed on the foundations of OpenFace. I moved to using a local server to house the AI, which was Ubuntu, rather than doing the identification on board, as this was quite poor on the Raspberry Pi. This move meant that training was only required on the local server rather than all devices. As with the TensorFlow implementation, I came across the open-set recognition issue where unknown people were being identified as known people. I have so far resolved this issue through the use of an unknown class that contained around 500 images of random people not available in the known datasets. Although this solution may not work across the board in cases like using the technology in public places, where it would interact with many different people, it works in small environments such as offices or homes. In an ongoing issue on the OpenFace GitHub repo, a number of people seem to have adopted my solution. For the fifth solution, the server used for the AI was rehomed onto an Intel NUC, which was kindly provided by Intel. The structure of the network also changed. The program that handled the facial recognition and identification would now connect to multiple IP cameras. Previously, the camera devices would send the frames through MQTT to the broker, which would then forward them to the local server. With this move, the identification process is more efficient, and also the camera devices only need to stream video. They do not need to connect to the communication broker, so third-party devices are now supported. I was very happy to be given the opportunity to demonstrate this project at the Intel booth at CodeMotion in Amsterdam this year. I met and worked with some really cool people at the booth, one being the former program manager, Francesco Baldassari. This was really cool as Francesco was the person that onboarded me onto the Innovator program, so it was really great to finally meet in person. In addition, this was the first time TAS had ever been tested in public, so I was excited but also very nervous. The demonstration of TAS included the OpenFace version of TAS and another project from the TechBubble IoT Jumpway GitHub repo that uses Serial to communicate with an Arduino Uno. This was a very simple proof of concept. In the event that a known person was detected, a blue LED attached to the Arduino was triggered, and in the event of an unknown person, a red LED and buzzer was triggered. The stream was quite slow and not real time, and this issue is something that has been solved in the latest version of TAS and TAS PVL, which I will tell you about soon. In a further addition to the system, I added in the ability for the hub to process frames from a RealSense camera and classify them. This massively increased the quality of the streams and the frames that were captured, and also reduced issues I was having with lighting. This version has also been open sourced, which is available on the TechBubble IoT Jumpway Intel repo. The version on the GitHub was developed on an Intel NUC, but any Linux device should work, which leads us on to the final version of TAS and TAS PVL. As you saw from the video, TAS PVL is the latest version of TAS to be open sourced. This version was created on an Intel NUC with Intel Optane memory and is currently available as a Windows command line application with desktop and Linux versions coming soon. TAS PVL uses the Intel Computer Vision SDK and specifically OpenCV PVL, which is Intel's own version of OpenCV. With all of the previous versions, a minimum of 10 to 30 images per person were required to train TAS to know who a known person was. With TAS PVL, it requires one image, which is handled through the console application by capturing the current frame when instructed to do so and saving that face in a known database. This is a massive improvement. Another feature that was massively improved is the facial identification of OpenCV. In previous versions, I had issues with lighting being a problem. This was partially resolved through moving towards using Intel RealSense cameras, but with the current version, I have yet to find an issue with this, even when using a standard webcam. The final most relevant improvement is the speed at which it can process the frames, identify people in the frames and whether it knows them or not, and play back the frames as a stream. Overall, TAS has massively improved through the use of the new NUC and the Intel Computer Vision SDK. I recorded a demonstration yesterday at our booth at Web Summit so that I could demonstrate the capabilities of TAS PVL in the wild to you. It was quite loud at the event, so it may be difficult for you to hear what I was saying. In the demonstration, I show how computer vision can work in conjunction with the IoT. The demo is similar to the one I presented at CodeMotion, except the communication is done directly between the device and TAS, rather than via an application that forwarded the commands through serial. At first, the visitor to the booth was unknown to TAS. You can see this by the red LED light in the bottom left-hand side of the screen. At this stage, TAS identifies an unknown user and sent a warning through the IoT jump to the Edison device, which is the IoT alarm example from our GitHub. Once I register the visitor as a known person, TAS is able to identify them anytime again in the future. You can see the blue LED light is triggered, which means TAS has identified a known user. The event was a total success yesterday and was the first time we had demonstrated this version in the wild. There was no issue with the lighting, the identification was very fast and could handle many people in the frame at the same time. I think during the day there was 5 times it misidentified someone, a few more times where they were facing TAS at a funny angle, but still I feel this is an amazing accomplishment due to the amount of people we had visit our booth during the day.
Okay, so at the moment, this is basically interesting to know who you are. So we're going to train it with the needs. So that's now identified you as person number 9. It's anonymous, it can be anything. So what's happening is on this device here, we've got it connected to the Internet of Things via MQTT. So what happens is when it doesn't know somebody, it turns the red light on. When it does know somebody, then it'll wait a little bit, there's a bit of a time delay. So the next time it sends a message, blue light will turn on. So this is a really simple use case of how the IoT and machine learning all work together. And this is built on Intel technology, and it's also using our internal computer vision technology and the computer vision SDK by Intel. So the idea is that this obviously a really easy to follow sort of IoT guide. It could be a number of different scenarios. One of the times that we created this demonstration, we did at the Intel we did that based on dependent family members. So if you have a grandma, maybe when she walks in the room, if the lights to your right, then it will recognise that as grandma and turn the lights down. Or it could be that maybe if she's walking out of the door and she's not supposed to, then you can alert somebody else in the house that she's got to walk out the door. And then obviously the security side. All start from the camera. This is an open source version of the project which you can download from our GitHub. It's a Windows application and we've got 2 versions available at the moment. It's totally free. I do a lot of Intel to get those source codes out to get that to work with computers and things like that.
There's two versions. One that uses the real sense, one that just uses the normal standard web app. You could put it up to the phone if you want to on the phone, but the actual nitty-gritty of everything is written on the Intel code. So this is where the machine learning is done, computer vision, and the IoT devices. It's just connected to Wi-Fi, and it's waiting for a response from whatever the output of this is. So each time this sensor expands through, then the device will pick that up.
The source code for this demonstration is available on our GitHub. If you search TechBubble Technologies GitHub on Google, it will bring us up, and this particular project is in the Intel Computer Vision SDK folder in the IoT Jumpway Intel examples. So that brings us to the end of my talk and demonstrations on how artificial intelligence and machine learning can be used in the Internet of Things. I hope you enjoyed the talk as much as I did developing the projects.